Good morning. We are continuing with the area rule, and we are slowly but surely going to move away from the right angle triangles, working out the area of those triangles, and we are going to move into Trig. We're using Trig, working with the area rule. Okay, so if I had to give you triangle ABC, and I would tell you that the perpendicular height is from B. Okay. If I want to get to basically a way to write h of 1, so the perpendicular height, I can say, hold on. Okay. If I have my my angle there, in this triangle that I have created here, because I can only label sides in right-angled triangles, using that half of the, well, not half, that bit of the triangle, this becomes my adjacent side, this is my opposite side, and this is my hypotenuse. I can also go and say, hold on, AC is side B, BC is side A, and AB is side C. Okay. So in terms of A, I can then say, if I use these two, sine of A is then my height over C, O over H. So H1 can be written as the length of side C times sine of A. Alright? So if I had to write down the area of triangle ABC, I can then have half base times perpendicular height, so half. In this entire triangle, the side the 90 degrees finds its base on is referred to as the base. So that's side AC, okay? But side AC can be written as B, and the perpendicular height, so H1, is written as C sine A. So I can work out that triangle's area by using half BC sine A. Some textbooks will go and write it as BC sine A over 2. Okay. Now what happens if I give you the same triangle, A, B, C, and I say to you, my perpendicular height drops down onto BC. So first of all, you can say to me that side BC is A, side AC is B, and side AB is C. I am going to choose one right-angled triangle, and in accordance to that, choose an angle which will make that my hypotenuse, my adjacent, and my opposite side. So in terms of C, I'm going to use sine, which is then my height over B. So my perpendicular height can be written as B sine C. So the area is then half base times height. The base of the triangle is the side where the perpendicular height finds itself. So instead of writing BC, I can write A, and then the height is B sine C. So if I keep my consistency as in the top, I can then go and say, right, hold on, that is AB sine C over 2. Okay. Now what if I give you the same triangle, A, B, C, so this is side A, side B, side C, and now I decide that the perpendicular height goes from angle C. So this means AB is the base. Right. Once again, I need to choose a 90-degree triangle so that I can identify the angle I'm working with. That will then be my adjacent, hypotenuse, and that's my third height, and opposite side. So looking at this, I am going to use sine of B is then going to equal the perpendicular height over A. So the perpendicular height is A sine B. So the area is then going to be a half base times perpendicular height. So the base is C and the height is A sine B. Okay, now why am I getting to this? Oh, sorry, let's just write AC sine B is then over 2. Why am I doing this all with you? This is showing you how they worked with the area rule. Now, before we write out the area rule, let's go and have a look. What are the similarities in each one? Because this is the same triangle. If I work with angle A, I'm going to use the two other sides, B and C. So if I work with angle A, I'm not touching side A. Okay? So work with angle A, I'm going to use B and C. So what do you notice? If I use the angle, I am using the two adjacent sides. Let's look at this one. If I use angle C, I'm not allowed to use side C, so I'm going to use side A and B. So there we go. So there's my angle, there's side B, there's side A. So every time I use the area rule, I'll use the angle and the two adjacent sides, so the included angle. Now let's look at this one. I'm using angle B, so I'm not allowed to use side B. So angle B combined with side A and C divided by 2 will give me, so let's see, so there's side C, there's angle B, there's side A. Okay, so what is the area rule? So that was just the explanation of how they got to the area rule. So this is theory, this you need to know. So they say that if I use angle A, so sine A, I will use side B and C. If I use sine of B, so angle B, I will use a half AC. If I use angle C, I will use a half AB. Okay, and this is what you will use when you work out the area of a triangle that is not 90 degrees. Okay, so if we look at some examples. Right, so if I say to you, you've got triangle PQR in which P has a length of 3,7. So first I have to go and say That will be side P, that will be side R, that will be side Q. So P is 3,7, Q is 5,2, and R is 112 degrees. Do you notice what they gave me? They gave me an included angle with two sides and an included angle. So the area, how am I going to write this now? So I have to use angle R, so sine of R. That means I will take a half and times it with side P and Q. So I will have a half times 3,7 times 5,2 sine of 112 degrees. Bum, ba-dum, bum. And I get the area. If it's two decimal places, it will be 8,92 units squared. Okay. Right, let's look at a second one. In triangle ABC, AC is 12, AB is 10, and angle A is 125 degrees. Okay, so I know that this will be an obtuse triangle because A is 125 degrees. I can put B and C wherever I want. That will be side A, side B, side C. They were nice and they gave it to me in terms of AC. That's 12 centimeters. AB is 10 centimeters. Do you once again notice the two sides with an included angle? So I can work out the area of this triangle ABC by saying it's a half. They gave me angle A, so I will have to use side B and C. Okay, so I have a half times by 12 times by 10 sine of 125. So I can, if you want to, that is 60. So 60 sine 125 works out to be 49,15, and this will be centimeters squared. Okay, another one. So determine the area of the following triangle. Okay. If I look at this, they gave me two angles and two sides. So they are trying to trick me because I have to work out the area of triangle DEF. But the angle I use needs to be included. So they gave me that 76,1 to confuse me. Okay. So I'm going to use sine of D. So I'm going to have to times a half by E and F. So a half times, this is side E, that's 7. That is side F, that's 5. And sine of 60. So sine of 60, and I get the area is 15,16, and once again I have units squared. Okay, so don't fall into that trap. That is not the angle I want to use. Right, there is an example 4, and that example you can find on page 303 in your textbook. I'm quickly going to talk you through it. So without the use of a calculator, so once again you will need to use your special angles. Side B, that's 8, Side C, that's 3. They want to know what is the size of A if the area is given. Okay, so I'm going to say the area, I have to work out A, so I'm going to use B and C together. The area is given as 6 square root 3. B is 8, C is 3, and I can get sine A. So sine A is going to be, to get rid of a half, I'm going to times by 2, and then I'm going to divide by 8 times 3, which is 24. Okay, so 6 times 2 is 12. 12 goes into 24 twice, so square root 3 over 2. Okay, so at this stage you had to do this, and that's 0, 2, so 1 square root 3, square root 2, square root 2, square root 3, and 1. And sine is O over H, so I'm going to look for O value, that's square root 3, and that I find at 60 degrees. Okay, now is that the only obvious answer for sine, for A? That is for an acute angle, correct? What if I made this an obtuse angle? But A can also be 180 minus 60, which is 120. That is the obtuse angle. Okay, so you're going to do exercise 11.3. There the numbers 1 A and B, 2 A and B, 3 B, C, and number 5.